This video is going to show how to do the floor wax problem in the course packet on page 123. So we have a floor wax product, and we have to decide between plastic and metal containers. So what we do is we package it in plastic containers and put it in stores 1 through 10, monitor the sales. At the same time, we use the metal containers in stores 11 through 20 and monitor sales. All right, so we're to type this into SPSS, or, well, this is going to be the R video, so let's go do that. I'm going to show a few extra tricks with R. One thing, you can have an editor, and often I find this editor to be pretty useful. So I just clicked on this thing up here, and now I have an editor window. And I'm going to make a data frame. Let's just call it wax. And I think I'm going to just type the data in directly. So let's have a data frame. And now the beauty of this editor is I can add some hard returns and make things look really nice. So make this a little bit bigger. Let's have our sales variable. Now I've already typed this in, so I'm just going to paste it. So I typed this in somewhere else. You're going to have to type all these numbers. And now I need to, notice I put a comma at the end of this. So I said, here are all these values, and they correspond exactly to what's in the course packet. So, 432, 360, and so forth. All right, now I need the stores. So, sorry, the material. So material, there's a lot of ways I can do this. Let's start with the simplest way, and then I'm going to make it better. So the simplest way would be for me to have 10 values of 1 and then 10 values of 2. So I could just type 1, 1, 1, 1, 1 a bunch of times, but I'd probably lose count. A better way is to say repeat the value 1 10 times and then repeat the value 2 10 times. Now if you want to see what this looks like, you can just highlight it all, and then on a Mac you hit Command return, and it submits it. So now if we go over to R, you'll see that now I have an object called wax. If I type it in, I have, well, here are my sales and materials 1 and 2. Now that's good enough. I'm totally fine if you do that, but let's make it a little prettier. I'm going to make it prettier by making this a factor. Now I'm going to put all this as a factor. Now I can add an additional option, which is labels equals, now I'm going to make this a vector. Let's have the first one, I think, was plastic, and might as well spell it right, huh? And then the other one is metal. Now if I highlight all this, hit Command Enter again, if we go type it, you'll see, lo and behold, now we have our labels. All right, part A we've done. Part B is make box plots and air bar plots. Well, we didn't talk about air bar plots yet, and it's not easy in R. You have to download a special package. I'm totally fine with you using, yeah. So let's go make our box plots. So remember box plot. And then the dependent variable here is sales, tilde the independent variable, and then my data set is wax. And let me bring that graph over from my other window. So what we see is that it looks like our sales are higher with plastic than with metal. There's an outlier down here I'm a little bit suspicious of. And so let's see, what is that outlier? Looks like it's that value 360. So first thing I worry about is, did I type it wrong? But no, sure enough, there is a 360 there. Okay, so it's always good to look at a box plot because you can identify these outliers. That's that second case. So forget about the air bar plots for this. You use analyze compare means to compare the means and standard deviations for plastic and metal. Well, we can't use compare means in R, we have to use tapply. So maybe the simplest thing is to attach wax. So it's going to attach this data set so I don't have to type wax dollar all the time. So let's do a tapply, and the first variable is the variable I want to do stuff to, so it's sales. Second variable is the index. Well, we want to do this by material. And then the third argument is going to be the function. So the function I want is mean. So this is saying the mean for plastic is 403. The mean sales is 403. The mean sales for metal is 390. And this confirms what we learned from the box plots. Let me bring those box plots back up. So sure enough, yeah, this is the median, but the mean's going to be roughly the same place. Now, we were asked for the standard deviation, so how do I get that? Well, with SD, if I want to know the number of cases, I type length here. And I could stick all of this in that editor window if I want. All right, let's go back to the course packet. And which material seems to have have higher sales? And note, we should really be doing a significance test. We'll learn this in Chapter 10. Well, I think we've already answered that. Looks like plastic does better. All right, how do we do a significance test? This is not, not going to be required until Chapter 10, but I'll show it in this video. The answer is we're going to do a t-test. So t.test does a significance test. If we say sales tilde material, we get our independent sample t-test. And what this says is the p-value is borderline significant. So it's a little bit bigger than 5%. So we can't reject the null hypothesis. However, we do have that outlier. So if we investigated that outlier and determined that there was something strange going on in that store, and we could come up with a reason to justify dropping it, we could see what would happen. So let's repeat this. Dropping, remember it was the second observation. So one way to drop this would be to say -2. That means drop the second row, a comma, meaning, okay, you give all the columns. And notice that now the p-value becomes borderline significant. What's happened is that standard deviation is inflated by the outlier, which makes it much harder to reject the null. So if you have a firm justification for dropping that store, like the distribution was screwed up, I didn't get the product out, there was something else was wrong, then you can make a case for dropping it. All right, good.